Oxidation of alkenes, we use the reagent first of all. For the oxidation of alkene is acidified or alkaline KMnO4, depending upon the situation. And there are two types. The first one was mild oxidation, which we did discuss in the last class. Today we are going to discuss the strong oxidation of alkene. In the mild oxidation, there was a diol that was formed. Okay. If I just quickly tell you, it was diol. Both these carbon having double bond, they converted into diol. Okay. Today we are going to discuss the second type, that is known as strong oxidation of alkene. Okay, please pay attention. The strong oxidation of alkene. Please pay attention. Uh, for this, the reagent used for the strong oxidation is the same KMnO4, but hot and concentrated. So hot, concentrated, acidified KMnO4. This is the reagent. And again, in order to make it hot, you have to heat under reflux. HUR means heat under reflux. जी मैं बताने लगा हूँ. So in this case, bacho, first I tell you, okay, when you have to, what is the meaning of reflux and distill? Look, if you have a container, a flask like this, and you put alkene into it, okay, and you mix it with KMnO4 and heat it. Listen, everyone. So once you mix and heat the KMnO4 with alkene, you know, alkenes, mostly they are gases, or even if they're not gases, they can vaporize. So what we do, we have to stop the alkene going out, turning into the vapors, right? So we cannot close this from the top because it's gonna build up the vapors inside and burst. So what we do, we attach a Liebig condenser in a vertical position like this. Here is the Liebig condenser. Okay, where the water in is here, water out is here. So water goes up and goes out of this container from here. Okay, and these vapors, they escape because otherwise they don't react. If you don't heat, the alkenes don't react with KMnO4. If they react, the diols and other products are formed. Okay, now if this condenser mean if there is no condenser, or if it's not working, all the vapors will escape. So in this position, these condensers, they don't let the vapors go out. As soon as the alkene vapors reach there, they return it back in the same container here. You got it? This is the reflux mean. It is reflux mean when the vapors of this mixture of alkene and KMnO4, they go up, they are condensed back in the same container to make sure that the reaction is complete, right? So reflux mean it avoids the escape of vapors. Okay, so similarly, इसका opposite भी एक होता है. If I tell you, for example, we want that vapors do not escape, we want to collect them, but in case we want to collect them in another container, so we use the same thing. We use the Liebig condenser, this condenser, but we use this condenser in this diagonal position. In this case, when you mix them, the vapors come out and then they go and collect in this container, this part of the container. Okay, so this is called distill. Later on, we'll see the difference between distill and reflux, but here I hope you understand. मेरे पास alkene है, I want it do not escape the vapors, and I want that the vapors should be in the same container so KMnO4 could fully oxidize it. So I will reflux. If I want the alkene vapors not to escape, but I want it to, whatever the first product formed by the oxidation, I want to collect it. So I'll distill it. So it could collect in another container. Okay. So this is the difference between the reflux and distill. We'll be using, especially when we'll go to alcohols, we'll be using this. कभी हम कहेंगे डिस्टिल करें, कभी हम कहेंगे रिफ्लक्स करें. जब हमें ये मेक श्योर करना होगा कि जो रिएक्टेंट है वो फाइनल प्रोडक्ट तक जाए तो हम रिफ्लक्स करेंगे. जब हमें ये मेक श्योर करना होगा नो वी डोंट वांट द फाइनल प्रोडक्ट, वी वांट अ इंटरमीडिएट और वी वांट द फर्स्ट प्रोडक्ट दैट इज टू बी फॉर्म्ड एंड कलेक्ट इट इमीडिएटली, तो फिर हमें डिस्टिल करना. ओके. Now coming back to the oxidation of alkenes. So there are, please write down, there are three different types of products. There are three different types of products formed by strong oxidation of alkene. What are these three products? First, I'll give you the general equation, and then precisely, I'm going to divide it into three parts like this. If your alkene is like this, one thing which you need to understand, that whenever the strong oxidation takes place, alkene ka molecule breaks from the place where there is a double bond. जहां डबल बॉन्ड होगा वहां से मॉलिक्यूल ब्रेक हो जाएगा, कट हो जाएगा. एल्कीन में जाहिर है 10 कार्बन है, 6 कार्बन के बाद डबल बॉन्ड है, तो वो 6 कार्बन वाली जगह से somebody has cut with the scissor, ऐसे समझ लें. ठीक है. और ये दो अलग अलग प्रोडक्ट्स बन जाएंगे, दिस साइड एंड दिस साइड. सिमिलरली नाउ, और सिर्फ ये दो कार्बन जिन पे डबल बॉन्ड है, दे विल अंडरगो ऑक्सीडेशन. Okay, and if now it depends कि product क्या होगा. Let me explain first go in one go. It depends कि product क्या होगा. आप देखो, for example, look at this. For example, if it is like this, there is a carbon chain and hydrogen. There is a carbon chain, armine carbon chain alkyl group. Okay, so if there is a carbon chain, again, this is a whole chain. But when the strong oxidation takes place, molecule कहाँ से break हो जाएगा? जहाँ carbon carbon double bond. Similarly, if there is another molecule like this, carbon chain, and even carbon chain on this side, double bond, carbon chain, and carbon chain on this side, यहाँ से molecule cut हो जाएगा. So first thing first, whatever the length of carbon chain is, where there is a double bond, molecule is going to break from that one. And खत्म हो जाएगा, कट हो जाएगा. यानी ये यहाँ से, यस, ये मॉलिक्यूल अलग हो गया, ये मॉलिक्यूल अलग हो गया. अब नाउ दीज टू कार्बन डिपेंड्स कि क्या है. लेट मी फिनिश. अगर तो इस कार्बन के साथ क्या अटैच है? दो हाइड्रोजन्स हैं. इफ देयर आर टू हाइड्रोजन्स, सो प्रोडक्ट, पहले वैसे एक और प्रोडक्ट बनेगा मेथनोइक एसिड, बट जस्ट फॉरगेट इट, हम फाइनल प्रोडक्ट लिखते हैं. कार्बन डाइऑक्साइड एंड वाटर इज फॉर्म्ड. इधर भी ये अलग हो गया, और दिस टू हाइड्रोजन्स अटैच विद दिस कार्बन, जिसकी ऑक्सीडेशन होनी है, तो क्या बन जाएगा? कार्बन डाइऑक्साइड एंड वाटर. राइट. इफ this is the situation, okay, no, the carbon that is having double bond, not two hydrogens, only one hydrogen, so फिर ये CH will become COOH, so RCOOH बन जाएगा, RC carboxylic acid बन जाएगा. Similarly ऑक्सीजन ना, ये हम ऑक्सीडेशन कर रहे हैं इसकी, so ऑक्सीजन प्रोवाइड कर रहे हैं. So सिर्फ इस कार्बन को ऑक्सीजन मिलेगा जिस पे डबल बॉन्ड है, और अगर उस पे एक हाइड्रोजन हुआ, CH हुआ, तो वो क्या बन जाएगा? COOH. और सेकेंडली आई सेड कि जो आर ग्रुप है उसकी कोई ऑक्सीडेशन नहीं होगी, देयर इज नो ऑक्सीडेशन. राइट. इसी तरह मैं बताता हूं. अब ये मॉलिक्यूल तो अलग हो गया ना, तो यहां से मॉलिक्यूल कट होके ये वाली साइज अलग हो जाएगी, और इस कार्बन की ऑक्सीडेशन होगी. हाउ मेनी हाइड्रोजन विद दिस कार्बन? वन. तो CH बिकम्स COOH. एंड एज आई सेड, इस R या बाकी कार्बन चेन की ऑक्सीडेशन नहीं होगी, वो एज इट इज रहेगा. ओके. नेक्स्ट, इफ देयर इज नो हाइड्रोजन, राइट, नो हाइड्रोजन नहीं, देन इस कार्बन की सिर्फ ऑक्सीडेशन होगी ना. सो इस कार्बन को C को क्या मिल जाएगा? O. तो फिर ये बन जाएगा C डबल बॉन्ड O एंड देन R हियर. सो व्हाट इज दिस थिंग? या इसको मैं अगर यूं ऊपर करके लिख लूं, इट इज अ कीटोन. राइट. सो इट्स अ कीटोन. राइट. और दूसरी साइड पे भी यू सी देयर इज अ वन कार्बन, सो दैट विल बिकम व्हाट? Ketone. But it will be, concept will be cleared once I'll give you the original example. Now keeping this thing in mind, now let me give you an original example. For example, this is an alkene, and I ask you if it undergoes the strong oxidation. For example, I reacted with a hot concentrated KMnO4, heat under reflux. Excuse me, can I have your undivided attention, please? Look at this. If this bond breaks from here, किन दो कार्बन की ऑक्सीडेशन होगी, बाकी मॉलिक्यूल अनचेंज रहेगा, एक इसकी होगी और एक इसकी होगी, इसका प्रोडक्ट अलग होगा, इसका प्रोडक्ट, यहां से किसी ने काट दिया कैंची से इसको, ओके। अब ये जो CH है ये क्या बन जाएगा, CH3 तो ऐसे ही रहेगा, CaOH, तो वन प्रोडक्ट इज एथेनोइक एसिड, एंड व्हाट अबाउट द अदर साइड? Yes, that's a straightforward thing. Okay. So similarly, if I give you a compound like this,
How do you know it's strong or not?
sorry,
How do you know it's strong?
conditions. If it is a hot concentrated, acidified and heat under reflux, strong oxidation. If it is just KMNO4, cold dilute, then yes, yes. So look at this. Then what about this? If this is strong oxidation, hot concentrated KMNO4,
CH3, CH2.
यहाँ से molecule is gonna break down, यहाँ से कट जाएगा. This part का CH will become what? So one product is CH3COOH. Another organic compound is what? यानी ethanoic acid, right? So आप सीधा करके भी लिख सकते हैं ऐसे CH3COOH, right? So it's a straightforward. For example, look, CH3, CH2, then CH3, double bond, CH, COOH. Okay, here is the product. Hot concentrated KMNO4, acidified, heat under reflux. Now you got it, it's a strong oxidation. So what happens? कहाँ से molecule कट जाएगा?
Center से double bond.
यहाँ से कैंची से काट दिया. Now, which two carbons will undergo oxidation? CH और C. इस साइड वाले मॉलिक्यूल के लिए CH will undergo oxidation और क्या बन जाएगा? COH. कंफ्यूज नहीं होना, ये ऑलरेडी COH है, that doesn't make difference, वो as it is रहेगा. और ये C क्या बन जाएगा? C डबल बॉन्ड O, जिसके इस साइड पे क्या है? CH3 और उस साइड पे क्या है? That's straightforward, right? For example, now I'm going to give you another one. Look, CH3, CH, double bond C, CH3, CH2, CH, double bond C, CH3, CH2, CH, C, CH3, double bond CH, 2. Okay, can you tell me, in this case, ये molecule एक जगह से नहीं कटेगा, यहाँ से कटेगा, is gonna cut from here, from here. ये product अलग होगा, ये product अलग होगा, ये product अलग होगा और ये product अलग होगा. ऐसे ही है? So multiple products are going to be formed, right? So can you please write for me the products that are formed, the structures of the products formed when hot concentrated KMNO4 is mixed with this alkene? Yeah, I'm going to show it again.
Can you zoom out the screen, please?
Done?
सर जो दो हाइड्रोजन होते हैं उसमें
CO2 और H2.
CO2 और H2 ऐड होता है तो वो क्या CH2 के साथ हम प्लस प्लस करके लिखेंगे या फिर सिर्फ वही दो प्रोडक्ट्स बनेंगे?
वही दो products. Done?
सर देखिए सर एक मिनट सवाल सुन सुन लीजिए प्लीज।
जी बेटे मैं कहाँ से सुनता हूँ?
नहीं तो आप पहले देखिए जो बाकी में कीटोन और कार्बोक्सिलिक ऐड होता है ना, तो CH2 में हम CO2 और H2 कहाँ ऐड करेंगे, मतलब तो पीछे कुछ होगा
ऐड क्या करना है?
सर जैसे
Okay, let me, if you give me the chance.
उस प्रोडक्ट को तो हमें सही नहीं लिखना होगा।
Yes, I'm going to read.
Right.
Okay, this is undergoing, excuse me. What is this part of the molecule?
Yeah.
CH3COOH. So multiple products are formed, Elia. So one of them is ethanoic acid plus. Now this carbon and this carbon is undergoing oxidation in the center part. So that carbon is going to become what? CH3. C becomes what?
Double bond.
C double bond O. Then CH2. Then CH becomes what? COH. So that's another product. Plus, right? So these are the multiple products. Then this C and this C undergoing oxidation. So what is formed? CH3, C double bond O, CH2, C double bond O, CH3 plus.
CO2 plus H2.
Yes. So the last part is CO2 and it is not adding in something. This is another product. So when you strong oxidation of this alkene, these are the multiple products formed. 1, 2, 3, 4, 5 things formed. और यहाँ से तो molecule वैसे ही अलग हो गया था ना. This part turned into carbon dioxide and water. Now, what was your question? Now, is it clear? Okay, here it is now. Strong oxidation of this, bachcho. What concentrated KMNO4 is mixed into this alkene? Please tell the product. What are the products?
I don't know. Sir, Asha wants to take the answer.
Asha, go ahead. Go ahead, please.
You put up and sir, yes,
Ilya, go ahead.
इसके लिए की है सर। तो ये किससे बात करिए फोन पे बार-बार।
Sir,
Ji.
the CH3COH plus CH3CH2CH2COH.
Two products?
Yes.
Unfortunately, wrong answer.
4.
There is only one product in this. It's just like this. Listen, everyone. Excuse me. In case of ring, if ring like this. So just it cuts from here and it opens like this. So first time when it's a ring, you just keep in mind that it's not going to be two products. The molecule will cut it from here. Okay. And then see what is this? We just have to see these two carbons. Ye kya hai? Are they CH? So they are going to turn into COOH. So that's the simplest thing to do. Just convert them into COOH. बाकी सारा molecule तो as it is copy करना है. और ये वाला भी COOH. तो इसी तरह लिखें इसको. That's a better idea. जी.
हमें टेबल पे आंसर उसमें लिखा था कि लाइक क्या-क्या प्रोडक्ट फॉर्म होंगे।
What do you mean?
तो मतलब ये जो बराबर टेबल बनाया था कि 3 तरह से वो डिवाइड होगा उसमें बताया था आपने।
जी. अब देखिए इसी को आप सीधा करके भी लिख सकते हैं. COOH And then here it is CH2, 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 CH2. और फिर आगे COOH. Here. Now is it clear now?
Yes, sir.
अब ये वाला करें, नीचे वाला part. जी. Here. Is it done?
Yes. एक कीटोन बनेगा और दूसरा COH का।
दूसरा नहीं है, एक ही प्रोडक्ट होगा इसमें.
कीटोन
The ketone or carboxylate like same. Yeah.
But only one product,
Yes.
not two products. So generally when alkene undergoes strong oxidation, they cut and turn into two products or three or four. But normally when it's a chain, then it opens two sides. Okay. For example, look, in this case, यहाँ से cut हो जाएगा. So what is this carbon and what is this carbon? जिनकी oxidation होनी है.
C or CH.
ये C है और ये CH है. ऐसे ही है. So C turns into C double bond O. So यहाँ तो C double bond O होगा. Next ऐसे ही है, ऐसे ही है, ऐसे ही है, ऐसे ही है, and then this becomes what? COOH. Okay. So you can either write it like this, that there is a ketone at carbon number 2, then 2, 3, 4, 5, 6, 3, 4, 5, 6, and then COOH. This is the product. You get it? Now, examiners, what do? They put the question in the other way around. What is the meaning of other way around? They ask you that this is an alkene. Sorry. This is an alkene that undergoes the strong oxidation to give two products. Right? This is a strong oxidation. Here it is, strong oxidation. And gives you two products. One of them is CH3, CH2, COOH, and the other one is CH3. First question, how many carbon in this alkene? इस alkene में कितने carbon होंगे? How many carbons in this alkene? Yes, you know कि ये दोनों कट के एक ही बड़े molecule से अलग हैं. So 3 carbon here and 2 carbon here. So I know it's a 5 carbon alkene. Then they ask you the structure. You learned a while ago कि COOH कब बनता है? जब वो कार्बन पे डबल बॉन्ड हो और उसके साथ कितने हाइड्रोजन अटैच हों? एक. और इसको मैं फिर इस तरह लिख देता हूं, CH3, CH2 and CH having double bond. अब दूसरी साइड वाला मॉलिक्यूल देखें, क्या that side is also COOH? So it was also CH and having double bond. So I'm gonna put it here now. Here it is CH. और उसके साथ next क्या attach है? CH3. So this is how you construct the structure for the alkene. Huh? Easy? For example, there is another alkene that undergoes oxidation to form this. How many in this? Can you construct the structure of alkene which undergoes strong oxidation to give this product? Please write the alkene ka structure. Aisha, can you switch the chair to the back?
They're done, sir.
This one? Can I see? At time they ask you,
No.
थोड़ा नीचे गए हैं क्वेश्चन
Here is the question. You have to draw the structure of alkene G. Now, first thing first, how many carbons in the alkene? 3 plus 4, 7. And now one thing which I got to know that CO जो होता है और दोनों तरफ CO है, that means 0 hydrogen are having the double bond. So first I'm gonna put this carbon here. CO की जगह C लिख देता हूँ, then put a double bond. और फिर उसके साथ दो कार्बन जो अटैच हैं वो क्या हैं? They are CH3s. So I'm gonna put one CH3 on this side and one CH3 on the other side. Please listen carefully how I did this. I just put ये जो C double bond O था उसको C double bond कर दिया और दोनों CH3s attach कर दिए. Now come to the other side. This CO भी क्या होगा? C double bond. Okay, and what are the two groups attached? CH2 and CH3, and what is the other group attached? CH3. So this is the structure, right? So at time they ask you, there is a strong oxidation of alkene to form only one product, and that product is propanoic acid. Can you tell me what alkene was this? Is it possible or not possible? Only one product. One product only. No, then cyclo होता तो दो functional group आ जाते हैं ना. There is only propanoic acid. This is the only product formed. Is it possible?
Yes.
Can you tell me the alkene's carbon? How many carbons alkene should have to undergo the strong oxidation if it could be any alkene? Because हमने तो कहा है वो कटता है और दो product बनते हैं. It is not possible? Why not? Because you have to cut the alkene. At least carbon dioxide, water तो होते साथ. If it is a terminal carbon, no, it is still possible. If the alkene is symmetrical and it's a 6-carbon alkene and the double bond is exactly in the center. Look, if the double bond is here और यहाँ से कटेगा और ये दोनों H हैं, ये भी H है और ये भी H है, तो ये वाली साइड भी क्या बन जाएगी? प्रोपेनोइक एसिड. ये वाली साइड भी क्या बन जाएगी? प्रोपेनोइक एसिड. So आप कहते हैं yes, it is hex 3-ene. When the alkene is symmetrical, I mean the double bond is exactly in the center, then two products that are formed, they are the same. Okay? They are always the same. Do you get it? Hex 3-ene. 3-ene. There is only one double bond. Hex 3-ene.
Sir?
Do you get it? Yes.
ये सब सिमेट्रिकल एल्कीन में होगा ये तो सिर्फ.
Yes, all symmetrical alkenes, when the double bond is right at the center, they always undergo strong oxidation to give only one product. CH है ना दोनों साइड्स पे.
एक साइड पे तो CH2 है ना,
दोनों तरफ H. Let me show you again. Let me show this again, please. Please, parents. This one. Oh, ask me what you are saying.
सर मैं कहीं भी डबल बॉन्ड होने के लिए दोनों साइड से CH होता है ना.
Yeah.
तो इधर एक साइड पे CH हो जाएगा, दूसरी साइड पे CH2 है ना.
No, there is CH again. Here is a double bond, na? So this is also CH and this is also CH. Okay?
इसमें क्यों नहीं हो सकता डबल बॉन्ड?
No, the product was propanoic acid. And the propanoic acid that is formed by the strong oxidation of an alkene. So I got to know कि अगर propanoic में 3 है तो 6 कार्बन वाली alkene होगी जिसके 3 के बाद डबल बॉन्ड है तो वहां से कट गया. ये सोचा मैंने. अब जैसे देख लो, it's not over yet. Hold on. There's an alkene C4H8. Yeah, but product एक ही है, उसके moles 2 बन गए. C4H8 is an alkene, बच्चों, right? It has 3 structural isomers. Please draw 3 structural isomers. P, Q, and R. Please write down this question. C4H8 is an alkene. Three structural isomers, P, Q, and R. When we did the strong oxidation, P gave C3H6O2 and CO2 and H2O. Q gives C2H4O2 only, and R gives no, thank you. R gives C3H6O, carbon dioxide, and water.
Last one is cycle, first one is.
No. Okay, now here you go. No, it's not a homework. It's a. Okay, fine.
Yes.
It's a homework. No, Galat banaya.